and also the compression. Okay. So let's just have a recap of AMP. So just a overview, like as we already know, like each Teradata AMP, it's a process in Linux machine, which is responsible of handling its individual share of data. And the assignment of this physical rows to the AMPs is done using the hashing algorithm, and it ensures that the rows are distributed across the AMPs. The distribution of data to virtual process is typical of shared netting, as we know already. And each AMP has its own memory and logical disk assigned. And the warehouse is built of 100 of AMPs simultaneously. Okay. And each Teradata AMP is capable of performing all tasks related to its own rows, which is stored. This includes of reading, sorting, aggregating, performing joins, locking the rows, sorting rows, disk space management, and conversion. So everything is done on the AMP level, as we saw in the earlier sessions. So this is about the overview. So now let's see about the AWTs. So AWT is nothing but a AMP worker task. Okay. So AMP worker tasks are the tasks inside each AMP that do the database work. So this work may related to a user request who submits a SQL or the internal database functionality, like avoiding or detecting a deadlock, error logging,
Okay.
or robots. Okay. So each AMP can assign a parallel steps, as we know, receive. And what will happen once the plan is received to a particular AMP, it has around 80 AWTs for one AMP. One second. Yeah, sorry. So each app has around 80 AWTs available. Okay, so this will help in the parallelism in the AMP level also. Earlier we saw parallelism is carried out by the AMPs. Okay, so inside the AMPs also 80 AMP worker tasks can do individual tasks inside that AMP. Okay. But there is a catch here. So the around means among these 80, 24 AWTs will be reserved for internal work. So this 24 AMP for each 24 AWT for each AMP. Okay. So this internal work in the sense like blocking or placing a log, deadlock situation. So those kind of internal database internal works. Okay. The remaining 56 AWTs will be available for serving the SQL requests, which the AMP gets. Okay. You got that right?
Yeah. Actually, whatever AMP that doing the work, no, the same kind of thing is done through AWT only, right?
Correct.
AWT.
Correct. So until now we saw like AMP is doing the work, AMP is fetching the data, AMP is writing the
no,
data.
under the AMP AWT AMP worker task will do these things, right?
Correct.
Activities.
Correct.
Okay.
Yeah. Like Teradata AWTs can perform different types of tasks, like depending on the plan which the AMP gets. So some work on a new request among these 56. Again, some will work on the new request which is coming to that AMP. other will continue with the existing works which is going on. And some are reserved for this tactical workloads. Tactical in the sense the queries which completes fast, which doesn't manipulate a lot of data. Okay, which runs less than a minute or 2 minutes, or less than 10 minutes, you can say. So those are tactical workloads. So this is how the AWTs are split and do the work in parallel. Okay.
Okay.
So different workloads. Workloads are nothing but the categorization of SQL. Like we have ETL workload, we have tactical workload, right? We have reporting workload. So depending on the workload type, the number of AMP worker tasks differ. Like how, like what number of AWTs are assigned to that workload. Okay. So a SQL statement means insert or update or select. Typically need 1 or 2 AWTs per AMP. Okay. So among these 56, 1 or 2 will be assigned for one request. So similarly,
Okay.
other AMPs, other AWTs from that AMP will perform the other requests parallel. It might be from other user also. Okay.
Okay.
So what? So like we'll see a scenario like when all the AWTs means we saw 56 for the request, right? SQL request. So when all the AWTs are assigned, so what will happen? So in that case, the PE aborts the task on all AMPs. So what will happen? If you submit a new job, right? So you'll be getting error like transaction is aborted. So that scenario, it's called as a flow control. So in each attempt, like this process continues until the AWTs are freed up. So you submit a request.
Hello.
Yeah, can you hear me?
Yeah, I can hear you. Yeah.
Okay, yeah. So I was telling like when you means when all the AWTs of one particular AMP is occupied, right? Like what will happen? Then the PE will abort all the tasks. Means abort the task on the AMPs, all the AMPs. Like initially it will do for 1 and then 2 and then 3. Whatever new jobs comes, right? It won't be able to accept. So existing job, the last come, it may abort. Okay. And then it will try to redo this process until the AWTs are available in the AMPs. So this process is called as flow control. Okay. So flow control means that some tasks cannot send more work to the busy AMPs. So busy in the sense like all the AWTs are occupied.
Okay.
So if many AMPs are in flow control, then the response time degrade. Yeah, because the AWTs are the one which is working, right? So when all of them are occupied, then there will be a performance degradation, obviously. As we know, like if CPU is 100%, right, in our system, then we can expect a degradation. So similar way for AWTs too. And this situation, right, it's bit serious, and we may miss the SLA jobs or prioritized jobs in this case. Okay.
Okay.
We don't have any control, direct flow control kind of thing. Maybe we can check like which SQL is consuming more AWTs, and then we can try to maybe kill. We can kill the session which is consuming more resource. So that is the only way. Yeah. So the amps, right? As we know, we can use that individually, means a single amp operation is there, or parallelly we can do to complete the task. So yeah, that's what it is saying. Yeah, one amp operation. Yeah, and also we know, like when a particular amp crashes, we have this fallback protection, and we have this hard standby, which will pitch in when the amp crashes or when a failure happens.
Okay.
And also these amps, right? We can monitor from the sorry, not amps, the AWTs we can monitor directly from the viewpoint. Okay. Maybe if time permits, I will show you today. You just need to click on the system health. It will show you like what are the AWTs currently running, how many percentage is there. Okay. And when we are talking about the compression, so Teradata compression is one of the several technique we can say uh, to store the data efficiently. So what this compression will basically do is it will reduce the amount of space physically stored in the drives by compressing the repeated values. This is the basic concept of compression. So
Okay.
Teradata uses a lossless compression method. So this means although the data is not compacted or compressed, there is no loss of information. So always the data will be 100% authentic and available. So some of the
Okay.
benefits of compression are like Teradata compression reduces the storage cost. So if we know, like the storage is the one which is costing more in the billing in case of Teradata. Even 1 TB of this space will be a very heavy amount in dollars. So in that case, if we were able to achieve storage space, save storage space, then it will be a great help for the customer too. And also performance will be improved because we have less amount of storage in the drive. So the IO
Okay.
will also be less, like the reads, the data should be read, right? So the reads will also be obviously less and the storage is less, correct? And yeah, and also when the decompression is happening, right? So it will be in the memory and cache. Okay, so instead of directly reading it from the disk, so thus the performance of the queries will also increase. So we'll see
Okay.
how this compression is carried out. And yeah, that's what we say, like the disk storage is reduced drastically. Yeah, so there are three types of compression here in Teradata. The first one is single value or multi-value compression. So this is the popularly used compression methodology across the accounts or projects. And the next one is algorithmic compression, and the third one is block level compression. Algorithmic compression, I suspect no one uses it. No. Mostly will be having this MVC, in some cases block level compression. Okay. So before going into the types, we'll see about how this compression works. Then we'll see about the types, different types. So compression works in conjunction with both the table header and each data type. If you remember in a previous session, we were seeing about the table header. We saw like compression data will be stored in the header. Okay, so that is what they are saying here. So when you create a table header is created on each AMP, as we know that. It will hold a grid of compressed columns and the compressed value option. Okay, so if you see this example, right? So suppose this is the table header. So what will happen? The data, if you compress a particular column. So if you see this employee table, they are compressing last name. Okay, so here after the data type, they are giving compressed keyword, and then they are giving the values. Okay, Smith, Wilson, Davis, and Jones. So what will happen? This Smith, Wilson, Davis, and Jones will be written into the table header. Okay, and the rows which is containing this last names, right? Those will be added with the some kind of bits. So that will indicate
Okay.
okay, Jones is the one for this bit, Davis is the one for another bit. So similarly, for all the values we have, the bits will differ. Okay.
No, that means only 2 bits available, right? 0 or 1.
Yeah, not okay, on a combination of bits, you can say. Not only
Okay.
not only 0 1. Like if you see here, it's no 0 0 0 and then 1.
Okay.
Yeah. So we'll see another example. So suppose we have a employee table, and then we do a compression on a job title. Okay, so if you see this example, the table header, these data will be stored like manager, system analyst, salesman, and LBC. Okay, and if you see, this is the presence bits will be stored along the rows. Okay, these values will be stored along the rows. So these values will be assigned to particular job title or the column.
Okay.
For
This
which,
okay, and this value is there. No, there is
Mhm.
combination of bits.
Mhm.
That is is something like based on the value or anything. Any logic is there assigning these bits?
No, there is no such hashing or some logic on that, but the database do
Okay.
it on its own.
Okay.
There might be some algorithm underneath, but we are not sure about that.
Okay.
Okay. So, so what will happen whenever a row with salesman comes, then no, the actual salesman data won't be stored, but instead that this presence bit will be inserted into the row. Okay, so how the space is saved here is, so consider for this salesman 2 byte of data or something is required to store. Okay, so when we have this presence bits, is just the bits, right? So it's consuming very less data. So when you have like thousands of entries for salesmen, so in that case, you can relate the difference. Okay, when the data is getting stored. Got it,
Okay.
right?
In place of that value, it will keep this bit as a reference. No.
Correct.
Okay. Okay.
So instead of storing the original value, the bits are stored, thus reducing the overall disk storage, disk space.
Okay.
Yeah. So let's see about the different types now. So the first one is single value or multi-value. So this type of compression is widely used in many environments, projects, data warehouse projects. So it's easy to implement and also can give good results in space savings. Okay, so MVC, it uses the dictionary to maintain the value of data. So that's what we saw. It uses a dictionary of names in the header, right? So while saving, Teradata replace the exact value with the bit pattern and save it, hence occupying much lesser space compared to the original data. So MVC again works on a column level only, and we should explicitly define for each column where the compression is required. So this is the syntax to compress the values. Okay, so so again, the problem with MVC is like you should know the repeative values. Okay, so suppose you have the last name to be the compressed column. So in that case, you should know all the last names which are repeating. So in that case, you can effectively use the compression, right? So once it is set right, you won't be able to modify the values once the compression is started. Okay. So this is an example of how you can compress the value in a.
And that means we cannot do update. You mean to say?
You can do alter, but that alter you can add a new row which is getting compressed.
No. In the sense like adding new compression value to that column means we should do alter. You're saying, right?
No, even that is not possible. Okay, let me tell. So suppose we are creating a table here called employee, right? So the last name is compressed here, right? So if you add a new, if you want to alter this, right, there is a way. We will see about that. Means if you want to change this last name also, right? If you want to include your name. So in that case, there is a way. So what we should do is we need to create a new structure, and then we need to add the value over there like an empty table, and then we need to insert all the data from here to there. That is the only way to modify a compression or to add a value. But if you want to just add another column, okay, consider city. So to this table. So in that case, you can just alter a table, add column city, and then you can compress again with the city names. Okay, but if you want to do any changes to the existing compression, then only way is to create a duplicate empty table. Whatever changes you want to do, you can make it over there, and then you can do a insert into the new table, select star from the old table. Okay, so while inserting only, the data will get compressed.
Oh, we cannot directly just add a new column doing alter statement, and
you can add a new column. You can add a new column. That's why you can add a new column called city in this existing, but you won't be able to change the existing compression values.
Okay. Say for example, if I want to add one more like John, okay, like right. John, if I want to add, right. In that case, I need to load this data into some other table, right? You're saying?
Correct. You need to create an empty table where you have the value of John here added here. And then you need to insert the value from this table to the new table.
Okay.
That's the only way.
Okay.
Yeah. So that's why.
And doing joining with this compressed value with respect to the uncompressed column, no? Anything, will it create any issue if we are doing a joining?
No performance issue. If you say it acts better than uncompressed data, because it need not to go and read the data from the drives, actual data from the drives, the disk. So it already has the rows where it has this data in the header. So it will directly pass that value to the result set. So when you're doing a join, you won't be facing any performance issues. You got that? Hello. Manjunath, can you hear me?
Yeah, I can hear you.
Yeah.
Sorry.
Okay. Yeah. So there won't be any performance issue when you're joining an uncompressed table with a compressed table. Okay. So these are some of the advantage of multi-valley compression. Okay. So you can assign multi-valley compression to columns that contain any of the below data types, like which has a zeros or blanks also. Okay. So the data types are byte, int, character, date, decimal, double precision, float, graphic, integer, real, small int, varchar, graphic. Okay. So all these data types you can compress on a column level. Okay. And also you can compress the columns that are component of the secondary index. Okay. If you see, we create a secondary index on the columns which are likely used apart from the primary index, right? We saw in early classes, right? So we can compress the columns on the second index also, but multi-load operations on a table, okay, with the secondary index can take longer time if the second index column is set to compress. So the best method when you're using a multi load is you can drop the secondary index before loading, and once the loading is completed, you can recreate that. So this is followed globally. So all the tables which is having secondary index columns, which is compressed, right? So we will drop the second index and then we'll load it and then we'll create the second index. And also if you just mention compress instead of giving any values, then defaultly all the nulls in the underlying columns will be compressed. And okay, one more thing is compress values are case specific. Okay, so if you see the example for compression of Manjunath in caps, we will not compress the Manjunath in small. So in that case, you need to give both the values. Okay.
Oh, it's case specific. Okay.
Right. Yeah. And also there is some limitations for this multi-value compression. So you cannot compress more than 255 distinct values for an individual column. Okay, suppose you have a column called last name. So in that last name, you can't give more than 255 distinct values. Okay.
Okay.
And also, yeah, so as we saw, you can't change the compress attribute for a column after it is defined. Okay. The workaround here will be, you can create a new table. You can do a insert into new table, select from the old table. Okay. Yeah, so you cannot also create a table with more bytes compressed than there is a room to store. Okay, so as we saw, the table header is the one which is storing the data, right? So once the table header is full or something, in case of huge table, right? So in that case, you cannot do a more compression. Okay. Means basically means if you give no extraordinary number of columns into compression, then that will also will be causing issue. And you cannot do a compression on the following ones. Like you can't have a compression on the primary index columns. You can't have a compression on volatile tables. No compression is allowed in the derived tables. And whenever we are having a row level security constraint columns, you can't do it. No, or a reference primary key we have in the table, you can't do it. And if there is a blob or blob or the no data types bigger for storing huge data. So in that case, if you're having a blob or glob, you won't be able to compress it. Okay.
Okay.
Yeah. So the next compression we'll be seeing is this algorithmic compression. So this type of compression uses an algorithm to compress and then to decompress the data. Okay, so it will use the no algorithm to compress before storing, and then while retrieving, it will do a decompress before giving it in the results.
Okay.
So there are few algorithms available in Teradata, and user can also add custom algorithms. You can create your own algorithm and use it also, creating new table. Okay. So the functions, right? The functions like the compress and decompress that are stored in this database called TD underscore system f1lib, means system function library. So this is the meaning of this table.
Okay,
So,
that means whatever the tables we are creating in that database, for all that one, it will apply implicitly, right?
no. So you're using these keywords, right? Compress using this compress, right? So it will be a function in background. Okay. If you're using algorithm, so that function details will be given in this TD sys f1lib. Okay, you can use the compression in any table from any database, but when you are using these keywords, so that will be stored here in the sys f1lib. That's what it means.
Okay.
Okay, so this is an example where you give you a column level using algo name. This is the algorithm name. And you can decompress. You need to specify both compress and decompress, like which algorithm it should use to compress the data and which algorithm it will use to decompress. Okay. So if you see here, it's compressing using ALG1 underscore name, and then it's decompressing with our reverse ALG1 underscore name. Okay. And one thing to keep in mind is this ALC.
Okay,
right?
now Okay, by doing this, it will automatically do the compression for repeating values.
Yes, it will automatically do the compression, not only for repeating values, like the multi-value compression is only for the repeating values. So the other compressions, it's for all the values.
Okay.
So this will do wherever possible, it will compress the storage. Like doing how to say, we do the zip, right? So similar kind of thing. Means in our Windows we do a zip, right? So whenever we are attaching something, we just select the folder and zip it. So similar kind of thing. So it won't see any repeating values and also it will compress all the values possible. Again, when we are using this ALC, it's very system or resource intensive. So nowadays we have systems with good CPU, so we can use this algorithmic. But on real time, we're not seen anyone using this algorithmic because mostly MVC will give you the required savings along with the block level compression.
Okay.
Yeah. So coming to this block level compression, so this compression is used to compress data at the block level. Okay, so the earlier two cases which we saw is on column level, but this one will be done on the block level and not on the column level. Okay. So the cold data and the data which is not accessed frequently is ideal for compression using BLC. Okay. So you shouldn't do it for a hard data, means a data or a table which is highly utilized in the system, frequently accessed in the system. So this PLC is recommended for cold data. So might be archival data kind of thing. Okay. And again, this BLC is also very resource intensive because it need to compress and decompress, right? So, but when you compare the space saved with the other compression methodologies, BLC will give you good result because the space is saved on the block level, right? So,
Okay.
So to enable this block level compression, right? So you need to set this query band like block level compression equal to yes for session. Okay, so what will happen? When you run this, block level compression will be enabled, and then after that you can start loading your jobs. So in that case, for whatever rows which is getting inserted, so block level compression will be automatically done.
Actually, this query band, what is the benefit? Actually, it will store whatever the information for that session in terms of how
Yes.
much they are consuming or what's happening.
Yes. Maybe we'll be seeing about the query band
Okay.
in a next session.
Okay. Yeah. Okay.
Yeah. So this query band will basically set the data about the queries which is run into the metadata. Maybe we'll be seeing that in query logging. Yeah, might be our tomorrow's class.
Okay. Because in a few of the projects I have seen, they have set a query band.
Yeah.
For the just to capture some details.
Correct.
And so to tracking purpose, okay, they have set a query band.
Yeah, to analyze what kind of activities, those kind of activities we need this query band.